I'm Sohrab Modi, and I'm a vice president in Sun's CTO office. I'm looking at distributed web scale technologies, in particular MapReduce and Hadoop. And I have with me here Chris Wensel. So Chris, perhaps you can introduce yourself.
Yeah, I'm Chris Wensel, founder of Concurrent Incorporated and developer of the Cascading open source project. I'm also a principal instructor at Scale Unlimited, where we teach an in-depth 2-day course on Hadoop. So Sohrab, what got you thinking about Hadoop and MapReduce and these kind of technologies?
Well, Chris, I've always been interested in distributed systems. And, barring sort of the high-performance computing or the supercomputing environments, distributed systems has had limited success. And I think part of the problem is that there just weren't enough cluster-aware applications to run in those environments. Right? Now, you sort of fast forward into this millennium, and you have these web applications. And not only are the web applications really well suited for a clustering environment, they have a demand which is which has requirements around the size and scale which are just absolutely astounding. Let me give you an example. Let's say you do a search for a query on Google or Yahoo. The search returns almost immediately with about 1 million entries, right? Right. And then it has all the relevant stuff right at the top. How does it do this? Well, it's done because Google and Yahoo pre-processed all this data. So they collected all this data from all around the world, and then they pre-processed it. Well, how much data are we talking about? It's about 14 petabytes of data, according to Google, in September of 2007. And I'm extrapolating a little bit here. And they required 370 machine years to actually process that data. So you can do this with a system, even a very large system in some quantified dollar amount, right? Right. And so you have to look at distributed systems, and this is really what got me interested in this technology. So what about you, Chris? What got you into this?
Well, distributed systems in general, I've been dealing with for about a dozen years. Hadoop specifically because recently I had a big data, complex problem issue, and Hadoop was the best application for the job. I quickly realized that it scaled linearly. Yeah. I could reduce complexity actually in my infrastructure. It helped me increase utilization in the hardware, and it allowed me to leverage my capacity properly, unlike traditional distributed systems. But there are a couple things missing. That's my project Cascading and the company that supports it. So can you explain what Hadoop is and why it's so effective?
Well, I'll certainly give it a shot, right? I'm not actually going to go into the implementation details of Hadoop. I think there's, or MapReduce, I think there's enough information out there to glean from. But what I want to start with, what exactly is Hadoop? And it's an open source implementation based on some of the design principles around Google's MapReduce. And Hadoop is both a programming paradigm as well as an execution paradigm. Right? It's sort of an overloaded term. And the problem that it actually tries to solve is it helps you manage your costs when you want to run data analytics on really very large, obscene amounts of data. Right? And it does this by actually leveraging the computational capabilities of a cluster. Right? But I think you pointed out in your just very recently, it's not only about scale out, right? It's also about managing your costs, which is very, very important, and it's also about simplicity. Right? It's a very simple programming environment, and it's a simple execution environment for a cluster that is, right? And of course, it also accommodates for failures, right? So, the obvious question is, well, what sort of analytics could you run, right? What sort of problems does it help solve? I think we talked about, search and indexing, right? But the other thing could be something like data mining, for example. And this could be, tracking user behavior, or it could be data transformations, things like, where you transform or you move large image objects, or you do conversions of, languages, for example. Or, there's other data structures also that can help you manage, right? But fundamentally, the way it works is it takes a very large piece of data, it breaks it up into little pieces and then distributes it to the various nodes of the cluster. And then the various nodes of the cluster actually execute these pieces in parallel and independently, and then they sort of feed back into each other, and then they follow the programming paradigm of map and reduce. And each node can actually be relatively inexpensive. You could have a single 4-core CPU with 8 gig of memory and a NIC card and about 4 disks, and you're good to go.